Today we're going to go over the last lesson of the chemical reactions unit. And after today, we should be able to identify the reactions and predict the products of both reactions, and then be able to balance, especially the combustion reactions. We're going to go over balancing them because they tend to be a little tricky as far as balancing them. They tend to go back and forth and back and forth. And I'll show you a shortcut on how to balance these types of reactions. So as far as predicting products, it's very simple because you're just switching one element with the other in each compound. Okay, so we're not going to use the activity series for these reactions. You're just going to assume the reaction occurs. The only time it might not occur is in single replacement reactions, and that's when you look at that list of metals to see if they will replace each other. You do not need this list for this. They are going to replace each other if I give you this setup. So basically you're just switching the two metals, and you will have copper oxalate and then beryllium sulfate. So all you're doing is just switching up the metals in the compounds. And then there's another type, that's the ionic compound double replacement. There's another type of double replacement for neutralization. And that's when you have an acid and a base reacting with each other. And it just yields a metal and a water. Okay, so for example, we have aluminum hydroxide plus nitric acid. So aluminum hydroxide is a base. Basically, if it has hydroxide in it, you can mostly assume that it's going to be a base. And then nitric acid is the way I remember naming acids, it's kind of stupid, but the ending, if it's ick, I ate something icky. So the ending you can change to nitrate. Okay, so how you do this reaction is you will be looking at aluminum, and the metal from the base will combine with the non-metal from the acid, and then the hydrogen and hydroxide will combine to form water. So you'll have the metal from the you'll have the metal from the base, and then you'll have the non-metal from the acid. Okay, so aluminum nitrate, and then the hydrogen and hydroxide. Remember, hydroxide is OH, and hydrogen is here, so you have two H's and an O. That's H2O. So all of the neutralization reactions look like this. Water is always the product, and depending on what that what is in front of the hydroxide and what is after the hydrogen, that will determine this compound right here. Okay, so predicting products on combustion, that's a little more tricky, a little more, I guess, memorization involved. So as far as predicting products for double replacement, that's simple. You're just switching two things. With combustion, you have to really look at what's in the reactant. So if there's carbon in the reactant, so on the left side of the arrow, if you see carbon, then you will have CO2 in the product. If you see hydrogen in the reactant, okay, you will see H2O. If you have sulfur in the reactant, you will have SO2. And if you have nitrogen in the reactant, you will have nitrogen in the product. And we're going to look at some examples. So you see here, you have basically in 10th grade, a combustion reaction. It's going to be something plus oxygen, and then you'll have some products over here. So this right here will always be in the reactants in a combustion reaction. So this is what you're looking at to determine this, okay, what the products will be. So I saw carbon in the reactants. It was CH4. So in the products should be CO2, okay? So you saw carbon, there was CO2, and then we also saw hydrogen, okay? So that means there needs to be H2O. So we have carbon, hydrogen, and then this is always here. You can kind of ignore it. It's kind of always going to be there in a combustion reaction in 10th grade. And we had carbon here, so that's why we put this, and we also had hydrogen here, so that's why we added water, and that's it. So we also have to balance this. And when you balance combustion reactions, they can tend to be a little tricky because they tend to go back and forth and changing numbers and stuff. So there is a trick. I'm sure you guys have already asked me in class. I know the kids usually ask me in class by this point, but if you haven't, no, not normal. No, you cannot put a decimal as a coefficient. However, you can put a decimal if you multiply it by 2. So like you can't put a decimal and leave it as your answer. If you find yourself needing to put a decimal, then you need to multiply it by a number that would cause it to be a whole number. You can't give me an answer as a decimal, but you can maybe use a decimal to kind of figure out the ratios of them, and then you'll just need to multiply it so that you can answer with a whole number. So we're going to go ahead and do the tally method as far as for the balancing just today. So we have 1 carbon here, we have 4 hydrogens here, and 2 oxygens on the reactant side. On the product side, we have 1 carbon here. We have, for hydrogen, we have 2 hydrogens here, and then oxygens, we have 2 here and 1 here. So 3. Now we just need to balance them. Carbons are balanced, but probably not for long. Hydrogen, we need 2 more over here. So if we added 2 here, we will have our 4. So carbon and hydrogen are balanced. So, sorry, we need to update our oxygen on this side. So we have 4 oxygens on this side because we have 2 here and 2 here. This 2 represents 2 oxygens. So we really just need 2 oxygens, 2 more oxygens. So we're going to put 2 molecules of O2, and that should be balanced. Everyone is happy now. So when you do this, I recommend you put the oxygen coefficient last. This way, anytime you have a single element or a diatomic element here, anywhere, it's best to balance those last because they tend to be easier. Here's another example. I'm sorry, I didn't want to jump into this, but hydrogen. Remember, this is a combustion reaction because oxygen is here. Here, we're going to look at this element or this compound to determine what's on this side. So we have hydrogen here. So one of our products will be H2O, if you'll remember from the table. And we have nitrogen here, so one of our products will be N2. So that's all you would do is you're adding the products. That's how you predict the products of a combustion reaction. And then we will balance it. So we have 3 hydrogens on our reactant side. We have 1, I was going to say 2 on our right, sorry. 1 nitrogen and then 2 oxygens. On the right side or the product side, we have 2 hydrogens. We have 2 nitrogens and 1 oxygen. So now we just need to kind of change these to make them balance according to the law of conservation of atoms. So we need to put a 3 here and a 2 over here. So a trick is if you have 3 and 2, they're not multiples of each other. Just put the 3 up here and the 2 over here, and they will be their lowest multiple that you could have gotten. The 3 will make this also have 3, and then 2 will be here, so that means we have 6. So our hydrogens are balanced. We need to update our nitrogen. Okay, so we have 2 nitrogens here, 2 nitrogens here. We have 6, 6, 2, 2, 2, and then we have an issue with our oxygens. So we could put 3 here, and then we'd need to start going back and forth changing. This is where those of you who either have thought or asked me, can you put a decimal here? So if we just need 1 more oxygen and we don't have to deal with all of this moving around, we could put 1.5. So 1.5 would mean 3 oxygens on this side. Okay, so you can do 1.5, but if you do 1.5, okay, make sure your final answer isn't this. If you multiply this by 2, you'll actually have your correct answer. So you'll have to multiply every coefficient by 2, and remember this is 1, okay? So that means this would be 4, this coefficient would be 3, this coefficient would be 6, and this one, remember it's 1. It would be now 2, Okay, and that would change all of these to this many atoms of each, and we're balanced. So we'll do a couple of practice problems, but just know that this is okay, but make sure the common mistakes I see is here. The kids will try to answer with this problem at this number, and that's not allowed. You need to have a whole number. And then here, they forget that there's a 1 here, so they don't add a 2, and then they get this portion of the problem wrong. So we'll just do like, I don't know, 1 or 2, 1 and 2, 12 and 13. Why it's numbered like this, I have no idea. Okay, so we'll do 12 and 13. Is it on here? No, I don't know. It just starts at 12. Maybe I copied it wrong. I don't know. Okay, so we have barium chloride and sodium phosphate. So this is double replacement. You can see the 2 ionic compounds. You can see the title here. You can see the title here. So it's double replacement. You're just going to switch these two and you're done. So again, with the single replacement, we use activity series sheets. With double replacement, we just assume the reaction is going to occur. So then you would have sodium chloride plus barium phosphate. Okay. Next one, we have lithium sulfate and magnesium nitrate, and honestly, this is one of the easiest ones. All you do is just switch. So then your products will be magnesium sulfate plus lithium nitrate. Okay. That's it. This is super easy. Let's do one with an acid maybe. Okay, so here's a neutralization reaction. So this is the only other one. All the others are either like this or a neutralization reaction. So how I like to do it is magnesium hydroxide is okay to stay because you have the metal and then your non-metal ion. Here it's not so distinguishable. You can't see which one we're switching. So I like to write for the acid, I always write the hydrogen first, and this goes true with pretty much any time we're predicting reactions, products for the reactions, hydrogen. And then I write its ion right here. So this was acetate here. Ic ends in 8. You really have to know those acid naming rules. If you don't, you're going to get a lot of problems wrong on the test because you won't be given those rules. And if you don't know how to predict what the non-metal or non-hydrogen ion was, then you're going to get the problem wrong every time, even if you know how to do it. So to write down the rules, hydro, ic, okay, the original ending to the ion was "ide", okay? If it's just something ic, the original ending was 8. And if there we go, if the ending is ous, the original ending was ite. There we go. Okay, so here are the naming rules of acids. Make sure you know them when you're doing this. That way you're not going to get something wrong just because you don't know how to name acids. That was last unit. You should know this by now. So basically it's not magnesium and hydrogen switching spots, okay? It's actually, so this is a neutralization reaction. So what's going to happen is, remember the one thing that's always produced in this type of reaction, and that's water. So it's going to be magnesium bonded with acetate. So it'll be magnesium acetate and water. Water is always produced in this reaction, in a neutralization reaction. Let's do a combustion reaction and we'll be done. Okay, so a combustion reaction, you just need to know what is on the other side. You need to know So do you notice that with combustion reactions, they all have oxygen as a reactant, and that's just a characteristic of a combustion reaction. That's how you're going to identify a combustion reaction. And then you're going to look at this part. You're going to look at this part to determine what the products will be. So remember that little table on the notes. If there's hydrogen present, that means there's going to be H2O. I should have given myself space to balance. And if there's carbon present, that means there's going to be CO2 as a product. And then if there is nitrogen present, there's going to be N2. So really you just look at what is in this one, the non-oxygen compound in the combustion reaction, and that's how you find your products. So for example, here we have hydrogen and sulfur, so that means we're going to have H2O plus SO2. Here we have carbon, CO2, hydrogen, H2O, nitrogen, N2. Okay, those are our products. Here, carbon, hydrogen, so you have CO2, H2, oops. Okay, so you're just doing that for predicting products. As far as balancing, you can do your tally method if you want to. I kind of do the, what's it called, trial and error method, really. So, I don't know, we can stay on this one. We have 2 hydrogens over here, so we for sure need to have that 2 starting out, and then that means we have 2 carbons. We have only 1 carbon here, so we have 2 carbons. 2 nitrogens, we have 2 nitrogens, so that's good. The only thing we need to check are oxygens. We have 4 oxygens here, 2 times 2 is 4, plus 1, so we have 5 oxygens. So we have 2 here, so if we put this as, if we utilize the decimal, then it will be a little helpful. So if we have 2 O2s, we have 4 oxygens, right? So if we want 1 more oxygen, because we have 5 over here, that would be 2.5, okay? Now, that's fine for now, but we can't leave this here, okay? We have to now multiply everything by 2. So that means this one would be 4, this one would be 5, this one, remember there's a 1 here, that's a very common mistake. The kids just leave it as nothing. This one is now 2, this one is now 4, this one is now 2. Okay, so that's how you would balance a combustion reaction. Always leave this guy last, and you can use the decimal here. Just multiply everything by 2 to make it easier. You could use the tally method if you want. I find the trial and error method a little easier, but for those of you in the beginning stages, you might want to see numbers and compare numbers, but whatever you want, do. Make sure to bring any questions to class. If you have any confusion about any of this, just let me know and we can go over it.